Hello students, this is again SDsir from the Temple of Excellence, Vidhyaashram Pre-University College, Mysore. Today I shall discuss session 3 on the topic potential and capacitance. What is my preview? What is that I discuss in today's discussion? Highlighting, I will derive a very important relation, a mathematical relationship between the so-called electric intensity and electric potential, and answering to many of my previous questions, I discuss something called as electrostatics of conductors. My dear friends, we will just recall the things done in previous session where I derived a meticulous derivation expression for potential due to isolated point charge. What was its form? V equals 1 by 4 pi epsilon naught charge by distance. And we also derived expression for potential due to system of charges. Now, continuing my discussion today, a very important 3-mark question also asked in 2020 physics paper, mathematical relationship between electric intensity and electric potential. ನಾವು ಪ್ರೀವಿಯಸ್ ಡೆಫಿನೇಷನ್ಗಳು ಓದಿದ್ವಲ್ಲ, ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಂದ್ರೆ ಏನು ಅಂತ, ಮತ್ತೆ ಎಲೆಕ್ಟ್ರಿಕ್ ಪೊಟೆನ್ಷಿಯಲ್ ಅಂದ್ರೆ ಏನು ಅಂತ. ಇವತ್ತು ಮ್ಯಾಥಮ್ಯಾಟಿಕಲ್ ಆಗಿ ಆ ಎರಡು ಕ್ವಾಂಟಿಟೀಸಿಗೆ ರಿಲೇಶನ್ಶಿಪ್ ಡಿರೈವ್ ಮಾಡೋಣ. ಹೌ ಡಿಡ್ ವಿ ಡಿಫೈನ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ? Very simple. I told it is the force that acts on a charge that is placed in the electric field. Intensity ಅಂದ್ರೆ ಏನು? ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಒಂದು ಚಾರ್ಜ್ ಇದ್ರೆ ಅದ್ರ ಮೇಲೆ ಎಕ್ಸರ್ಟ್ ಆಗೋ ಫೋರ್ಸ್ನ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ ಅಂತ ಕರೆದ್ವಿ. What was potential? Very simple. Work done to move a charge from infinity to a point inside the electric field. So in my book work now, mathematically, I will start relating these two quantities. Now, for my derivation again, what do I require? A point charge, what we call as a source charge. I will consider a source charge plus Q. Why is this the source charge? Very evidently again, it will create the electric field. All these things clearly umpty number of times I have discussed in the previous session. So plus Q is the point charge, or what we call as the source charge, which creates this electric field. How do I consider, or how do I treat the influence of this field? Again, test charge UPC at some distance from this source charge. And the field acts away from the UPC. All these things we have studied in the previous derivation. Now I assume that the test charge is placed at the point A of the electric field. What is my consideration? I have placed the test charge UPC at the point A of the electric field. And what is my task? I have to move the test charge to the point B within the same electric field. Please do note that I have to move the test charge from the point A to the point B within the same electric field. And I say both these points are separated by a small distance, what I call as dx. So dx is the distance of separation between the 2 points. So ಎಲ್ಲಿ ಪ್ಲೇಸ್ ಮಾಡಿದ್ದೀನಿ UPC ನ ಪಾಯಿಂಟ್ A ನಲ್ಲಿ within the same electric field. ಆ electric field ಅಲ್ಲಿ I am moving it to the point B. The displacement is very small, what I call as dx. To recall, how can I move the charge? I have to do some small amount of work. Why small amount of work? Because the displacement is small. So how will I calculate that work? My previous derivation, very clearly I told work done is force into displacement. ಇದನ್ನೆಲ್ಲ previous derivation ಅಲ್ಲೇ ಮಾಡಿದ್ದೀನಿ. Work done equals force into displacement. So dW equals vector F dot vector dx. ಇಲ್ಲಿ ಸದ್ಯಕ್ಕೆ ಫೋರ್ಸ್ ನ ವೆಕ್ಟರ್ ಎಫ್ ಅಂತ ಕರಿತೀನಿ, ಡಿಸ್ಪ್ಲೇಸ್ಮೆಂಟ್ ನ ವೆಕ್ಟರ್ dx ಅಂತ ಕರಿತೀನಿ. Again, if you observe beautifully, a dot product of force and displacement. So how did we expand vector A dot vector B? It was AB cos theta. So how will I expand vector F dot vector dx? F dx cos theta. So I have expanded vector F dot vector dx using cross product method, which is F dx cos theta. Again from the previous derivation, what was theta? Electric intensity in this direction. Applied force into the field. They are acting in opposite directions along the same straight line. So theta is equal to 180 degrees. Again we know cos 180, the value of cos 180 is -1. So dW equals minus F dx. So again I repeat, I am calculating the small amount of work required to move my charge from the point A to the point B, where the displacement is very small, what I call as dx. So mechanically, by the definition of work is force into displacement. Small amount of work is happening. Why small amount of work? Since displacement is small. So dW equals vector F dot vector dx. Cross product expansion, dW equals F dx cos theta. What is theta? 180 degrees. Why? The intensity, direction of the electric field and the applied force along the same straight line but opposite to each other. And what was the value of cos 180? Minus 1. So dW equals minus F dx. My dear students, concentrate on this minus F. Yenadu F? Force acting on the UPC. What did I normally call it as? Electric field or electric intensity. Therefore, if you observe, my expression also turns out to be dW equals minus E dx. From where did I get this minus E? Force acting on the UPC, on the charge placed in the field, intensity. Now, my next question is, what is this dW? Small amount of work to move the charge from the point A to the point B within the same electric field. Recall ಮಾಡ್ಕೊಳ್ಳಿ ಈ ಸ್ಟೇಟ್ಮೆಂಟ್ ನ prior ಆಗೆಲ್ಲ ಉಪಯೋಗಿಸಿದ್ದೀನಿ. What is dW? Small amount of work to move the charge from A to B, 2 points within the same electric field. And what did I call it as? I called it as electric potential difference. So if you remember, we defined potential difference. What was potential difference? Work done to move the charge between any 2 points within the same electric field, potential difference. Therefore, I write dW equals dV. So, substituting here, dV equals minus E dx. Again, why I am substituting dW as dV? Work done to move the charge from one point to another within the same field is nothing but potential difference. Therefore, dW is nothing but dV. And from this expression, E, electric field, is minus dV by dx, a very established relation. E equals minus dV by dx. What was E? Electric intensity. What is dV? Electric potential. Have I not related intensity and potential? Yes. So what is the relation between them? E, intensity, is minus dV by dx. Now the consequence is very important. What do we call dV by dx as? Your mechanics told any physical quantity divided by distance taken as the ratio of distance is called gradient. Length by distance, length gradient. Mass divided by distance, mass gradient, and this is potential by distance, which is called potential gradient. Repeat ಮಾಡ್ತೀನಿ. ಯಾವುದೇ ಒಂದು ಫಿಸಿಕಲ್ ಕ್ವಾಂಟಿಟಿನ ಡಿಸ್ಟೆನ್ಸ್ ಇಂದ ಡಿವೈಡ್ ಮಾಡಿದ್ರೆ, ಡಿಸ್ಟೆನ್ಸ್ ಇನ ರೇಷಿಯೋ ತಗೊಂಡ್ರೆ ಅದನ್ನ ಗ್ರೇಡಿಯಂಟ್ ಅಂತ ಕರಿತೀವಿ. This is potential divided by distance, dV divided by dx. That is what is called potential gradient. So E, electric intensity, dV by dx, potential gradient. So what do I conclude? You consider any point in the electric field. ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಒಳಗೆ ಯಾವುದೇ ಒಂದು ಪಾಯಿಂಟ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ರೆ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಇಂಟೆನ್ಸಿಟಿ should be the negative of the potential gradient anywhere within the field. At any point of the electric field, please do remember, electric intensity, field strength is always negative of potential gradient. So please do understand, my friends, the relation between potential and intensity many a times are used in current electricity. E equals minus dV by dx. Now I consider some point in the electric field where potential is a constant. Then what happens to electric intensity at that point? Question ಏನು? ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕನ್ಸಿಡರ್ ಮಾಡಿದ್ದೀನಿ, and inside that electric field there is a point where electric potential is constant. Then what is the magnitude of the field strength there? I say electric field strength at this point is 0. Why? Again, E equals minus dV by dx. If V is a constant, if potential is constant, your basic calculus told differentiation of any constant is 0. ಇಲ್ಲಿ V ಕಾನ್ಸ್ಟೆಂಟ್ ಆದ್ರೆ dV by dx has to be 0. ಅಂದ್ರೆ electric field becomes 0. So please understand, wherever in the electric field, any region of the field, if potential remains constant, then electric field strength is always 0. So I want you all to remember 3 mega points here. First, electric intensity and electric potential related by the expression E equals minus dV by dx. What did we call dV by dx as? Electric potential. So any point of the field, electric intensity is negative of the potential gradient. And what if the potential is constant at a point? Electric field there has to be 0. Why? Differentiation of a constant is always 0. So nab your minds, E is always minus dV by dx. Here is a bookwork for you. Pick up the expression for electric potential due to a dipole. I have already derived an expression for potential due to a point charge. And I want you all to do the comparison between them. ಏನು ಮಾಡ್ತೀರಾ? First, potential at a point due to a dipole ಬರ್ಕೊಳ್ಳಿ. ನನ್ನ previous session ಅಲ್ಲಿ potential due to an isolated point charge na derive ಮಾಡಿದ್ದೀನಿ. I want you all to compare a comparative analysis between these two potentials. Hope you take it up seriously. Comparative analysis of electric potentials at a point. First due to a dipole and then due to an isolated point charge. Now, this is very important. These are all justifications or conclusions to whatever questions that were pondering before, may be asked as give reasons in your exam. Electrostatics of conductors. As I told, certain justifications will be done, certain concepts will be justified. Which is the first concept? The first concept is the net electric field in the interior of a conductor is always zero. Sumar sati badkonde. The net electric field at the interior of a conductor is zero. There is no net electric field inside any conductor. Why? The justification will happen now. To begin with, I will consider a conductor. My dear students, from where is this conductor acquiring the conducting property? ಯಾವ ರೀಸನ್ನಿಂದ ಒಂದು ಕಂಡಕ್ಟರ್ ಆ ಪ್ರಾಪರ್ಟಿನ ಎಕ್ವೈರ್ ಮಾಡಿಕೊಳ್ಳುತ್ತೆ? Please to understand, it is always because of the presence of free electrons in it. ನಾವೇನು ಹೇಳ್ತೀವಂದ್ರೆ, a conductor always has large number of free electrons, mobile electrons, and therefore it has got conducting property. So, simple thing to understand, any conductor will have large number of free electrons. Now what I do is, I will apply an electric field to this conductor. ಒಂದು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ನ ಆ ಕಂಡಕ್ಟರಿಗೆ ಅಪ್ಲೈ ಮಾಡ್ತಿದ್ದೀನಿ. How do I apply electric field? Beautifully, the next chapter you will know, connect it to a battery, a source. What will happen? Electric field is applied. So now what has happened? There are large number of free electrons in the conductor. I am applying an electric field to the conductor. So what is the immediate consequence? Electric field na apply ಮಾಡಿದ ತಕ್ಷಣ ಏನಾಗಬೇಕು? The electric field should exert some force on the free electrons. Alva? Electrostatic influence. Immediately the electric field should apply some electrostatic force, and we know that electrostatic force can be calculated by the relation E equals F by Q. ಉಪಯೋಗಿಸಿದೀನ ಇದನ್ನೆಲ್ಲಾದರೂ? Yes. When I defined intensity, I told E equals F divided by Q. So here EA, applied electric field, equals F, which is the force, divided by free electrons alva, charge of the electron, which is minus E. So EA, applied electric field, which is equal to F divided by minus E, where minus E is the charge of the electron, or F equals minus EA into E. So I repeat, the moment electric field is applied, it will exert some force on the free electrons, which can be calculated as E equals F by Q. Here E is the applied electric field. EA equals force F divided by the charge of the electron, which is minus E. Or from here, the force is given by minus EA into E. A very conclusive expression. What do I understand from this? Very clearly I can see the free electrons are experiencing force opposite to the direction of the electric field. Very, very clearly, dear students. What is happening? The free electrons will experience the electric force opposite to the direction of the electric field. Clear gamansi, F equals minus E into A, which means the free electrons acquire some force opposite to the direction of the field. So the summary what I want to say here is, the moment this electric field is applied, the free electrons of the conductor experience force opposite to the direction of the electric field. Now, because of this consequence, there is redistribution of charges. Andre, one surface of the conductor, all positive charges are accumulated, and the other surface, negative charges come into picture, exactly like your capacitor studying next. Now I want you all to remember, because of this consequence, where force on the electrons is opposite to the direction of the field, there is redistribution of charges. The charges get redistributed on the surface of the conductor. One end completely positive charges are accumulated, other end it is negative. Because of this redistribution, now there is an induced electric field. There is an induced electric field on the surface. ಚಾರ್ಜಸ್ ರೀಡಿಸ್ಟ್ರಿಬ್ಯೂಟ್ ಆಗ್ತಿರೋದ್ರಿಂದ ಒಂದು ಎಂಡು ಬರೀ ಪಾಸಿಟಿವ್ ಚಾರ್ಜಸ್ ಇರೋದ್ರಿಂದ ಇನ್ನೊಂದು ಎಂಡು ಬರೀ ನೆಗೆಟಿವ್ ಚಾರ್ಜಸ್ ಇರೋದ್ರಿಂದ ದೇರ್ ಇಸ್ ಅನ್ ಇಂಡ್ಯೂಸ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ whose magnitude is same as the applied electric field. Beautiful ಆಗಿದೆ ನೋಡಿ. ಈ ಅಪ್ಲೈಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಮತ್ತೆ ಇಂಡ್ಯೂಸ್ಡ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಇರುತ್ತಲ್ವಾ, ಅದ್ರದ್ದು ಮ್ಯಾಗ್ನಿಟ್ಯೂಡ್ ಸೇಮ್ ಆಗಿರುತ್ತೆ. ಆ ಎರಡೂ ಫೀಲ್ಡ್ ಸ್ಟ್ರೆಂತ್ ಸೇಮ್ ಇರುತ್ತೆ. ಬಟ್ ವೆರಿ ಕ್ಲಿಯರ್ಲಿ they are acting in opposite directions. Beautiful. Both of them will have the same magnitude, both the applied and the induced field, but they are acting in opposite direction. Andre resultant field enagoytu? Zero. This is the reason we say the net electric field or the resultant electric field in the interior of a conductor is zero, only because the basic consequence, due to the applied field, force is opposite to the direction of the applied field, redistribution of charges, because of which what happens? Induced electric field, both of them same magnitude but opposite to each other. Therefore the net electric field in the interior of a conductor is zero. Now we say electric field at the surface of a charged conductor is perpendicular to the surface of the conductor. Gauss theorem na ನೀವು ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ, applications ನ ನೆನಪು ಮಾಡ್ಕೊಳ್ಳಿ. What do we say? Electric field is always radial to the surface. ಉಪಯೋಗಿಸಿದ್ನಲ್ವಾ? Electric field always acts along the normal. We clearly told that electric field is perpendicular to the surface. Why? The answer is here. Now again I'll consider an electric field. Now I assume that electric field is not perpendicular to the surface and prove that wrong. Contrary of this statement establish ಮಾಡ್ತೀನಿ. I will assume that electric field is non-radial to the surface, non-perpendicular to the surface, and then prove it is wrong. So what do? I will consider this as the direction of the electric field. If electric field is not perpendicular to the surface, it has to make some angle theta with the surface ಅಲ್ವಾ. ನಾನು ಎಲೆಕ್ಟ್ರಿಕ್ ಫೀಲ್ಡ್ ಕೊಟ್ಟಿರೋ ಸರ್ಫೇಸಿಗೆ ನಾನ್ ರೇಡಿಯಲ್ ಆಗಿದೆ ಅನ್ಕೊಂಡ್ರೆ, ಅಂದ್ರೆ ಪರ್ಪೆಂಡಿಕ್ಯುಲರ್ ಆಗಿಲ್ಲ ಅಂತ ಅನ್ಕೊಂಡ್ರೆ, it will define an angle theta with the field. If there is an angle here, there will be a component along the normal which we call as E cos theta. What is this E cos theta? Component of the electric field along the normal, a tangential component. I repeat, electric field is not perpendicular to the surface. It is making an angle theta to the surface. Andre there is a tangential component E cos theta. So what is E cos theta? A component acting along the tangent. If this is the case, if there is a tangential component, what should be the implication? First PUC mechanics told, Whenever a tangent is drawn, it will indicate the direction of velocity. So dear friends, wherever we draw tangents, very clearly it will indicate the direction of velocity. Here this tangential component will indicate the velocity of charges, which is not possible. Electrostatics ottiddive, static charges. So please to understand, E cos theta, which is the tangential component of the field along the tangent, indicates the velocity of charges on the surface. Not possible. Electrostatics, there are charges at rest. That clearly shows E cos theta is 0. It cannot exist at all. There is no performance of this tangential component. E cannot be 0. There is an electric field. It will have some strength. So this clearly means cos theta is 0 or theta is 90 degrees. When I clearly say theta is 90 degrees, it is showing me that field is perpendicular to the given surface. So electric field at any surface is radial to the surface. Now, last part of the session, net charges inside a conductor is 0. ನಾನು ಮೊದಲನೇ ಸೆಷನ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೆ, ಪ್ರಾಪರ್ಟೀಸ್ ಆಫ್ ಎಲೆಕ್ಟ್ರಿಕ್ ಚಾರ್ಜಸ್ ಹೇಳಬೇಕಾದ್ರೆ ಟೋಟಲ್ ಚಾರ್ಜಸ್ inside a conductor is 0. Why? This is the answer. If I consider Gauss law, phi equals 1 by epsilon naught times summation Q. Electric flux is 1 by summation times Q, epsilon naught summation type Q. And again we wrote phi is E summation ds. E cos theta ds. E was along the normal, so theta was 0. So phi is E summation ds. So artha ಮಾಡ್ಕೊಳ್ಳಿ, Gauss law ಏನು ಹೇಳ್ತು? Phi equals 1 divided by epsilon naught summation Q. Charges on the surface. Also phi was E summation ds. Now I told at the interior E has to be 0. So substituting for phi, E summation ds is 1 by epsilon naught Q. Inside the conductor, E is already 0. For E to be 0, what has to be 0 on the right hand side? Epsilon naught has a defined value, a constant. So my only option is Q has to be 0. That is the reason we say there are no charges present at the interior of the conductor. Inside a conductor, the total charges present is 0 because of this. Yake? Gauss law told flux equals 1 by epsilon naught summation Q. We also wrote flux as E summation ds. What was the net field inside a conductor? 0. So E summation ds was 1 by epsilon naught Q. If E has to be 0, Q has to be 0. Epsilon naught is a defined value. That is the reason we told there are no charges at the interior of a conductor. So students, I hope you have understood today's session. Please do jot up with the assignment given. Work on the relationship between intensity and potential. Understand the justifications. Stay safe until we meet for the next session. Thank you.